All right, we're going to continue working with our equations of lines. However, now we're going to start gearing them towards the geometry aspect. All right, so we're going to talk some parallel and perpendicular slopes. So parallel slope, if it's going to be parallel, the slope will be the same. This is a review from Algebra 1. Right, but parallel and perpendicular are associated with geometry. Perpendicular will be opposite reciprocal. Now, what do each of these mean? Mainly, actually, probably just the perpendicular one, but let's do both for fun. If it's the same slope, like say if I had y equals 3x plus 1, well, my slope would be 3, right? That would be my parallel slope. My parallel slope is the same. Now, for perpendicular, let's take the same equation. My perpendicular slope would be the opposite reciprocal, meaning the opposite sign, so negative, and then the reciprocal of 3, which is 1 over 3. Okay? If I had y equals negative 2/5 x plus 7, my perpendicular slope would be positive 5 over 2. Flip it and negate it is what you'll often hear. Okay? Let's use them. Let's write the equation of a line parallel to y equals 2x minus 5 that passes through negative 1, 3. This is back to the first day video. I need a slope and I need a y-intercept, right? Those are the two things I need. Well, it says that it's parallel to y equals 2x minus 5, so my slope, if I could get that to circle the correct spot, my slope is going to be that too, right? Parallel slopes are the same. Cool, I've already got the slope. How do I find my y-intercept? I can use this as my x, comma, y. I can use it as my x and y values of y equals mx plus b. So I will plug those in. My y is 3. My m we already know is 2. My x is negative 1 plus b. So I get 3 equals negative 2 plus b. So b equals 5. All right, so I get y equals mx plus b. The x and y are variables. They stay, but my m and my b are those two numbers that we plugged in. Cool. Awesome. All right, so we took care of parallel. I wonder what's next. So we're going to write the equation of the line perpendicular to y equals negative 3x plus 2 that passes through 6, negative 7. Again, I need my slope and my y-intercept. That is a terrible B. That's a lot better. Okay. Well, my slope here is negative 3, so what's my perpendicular slope? I'll even put that there, my perpendicular slope. That would be positive 1/3, right? Change the sign and flip it. Positive 1/3. Cool. I don't know what B is, but I can figure it out. Take my y equals mx plus b, mx plus b, not ms, plus b. Y equals mx plus b, and I'll plug in what I know. I got x is 6, y is negative 7, so negative 7 equals 1/3 times 6 plus b. Alrighty, so this becomes 1/3 times 6 is 2 plus b. Subtract it over, I get negative 9 equals b. So my final answer here, y equals 1/3 x minus 9. All right. Wonderful. This should still be pretty much algebra review here, guys, but because we're using those words, parallel and perpendicular, and associating that with our slopes, it's a bit of a geometry concept too. All right, last one here, and this is where the geometry terminology really comes into play. Write the equation of the perpendicular bisector of line segment AB. Whoa, man, you're throwing back words from a while ago, okay? Perpendicular bisector, well, I mean, what the heck does that mean? It's, I guess, exactly what it sounds like. It's perpendicular and it bisects. What does it mean to bisect? It means to go right through the middle. It splits it in half, right? Okay, so my perpendicular bisector is going to look something like that, right? It's going to split it in half, and it's going to be perpendicular to it, meaning it's going to form a right angle. Okay, well, what do I need to write an equation of a line? I need a couple points so that I can get my slope and my y-intercept. Ideally, we just get our slope and y-intercept, but at least a couple points we can go from there. So what's a point that would be on this perpendicular bisector? Well, this guy right here would be on that, right? And that is the middle of A and B. Sounds like we need to do midpoint. Midpoint. So what's my midpoint there? What is this guy going to be? Well, A, I'm going to write down my coordinates so it's a little easier. A is 1, 2, 3, 4, -4, comma, and then -5. And then B is, looks like 0, comma, that's a terrible 0. It's like when you guys write those on tests and it looks like a 6. 0, comma, 3. All right. So I got to find my midpoint of that. So -4 plus 0 over 2, comma, -5 plus 3 over 2. So that looks like -4 over 2 is -2. And -5 plus 3 is -2 over 2, which is -1. So -2, comma, -1 for my midpoint. So that's a point that's on the line. I can use that. That's important. Now, I need something else, right? I need either another point on that line, which I don't know exactly where it's going, or I can find my slope. I'm going to jot this down as a reminder. I like to do that actually at the beginning of each one. I don't know why I didn't do that. It's a weird B again. There we go. All right. I don't know either of those, but I have a question. Could I find my slope of AB and then figure out what's perpendicular to that? Yes, I could. So let's do that. My slope of AB. Slope of AB. Let's do that work now. So if I were to do that, I'd have my change in Y, which is, let's see here, I'll go -5 minus 3 over my change in X. Start with the same ordered pair, -4. Because I started with the -5 in that ordered pair, I got to start with it. I don't know why I put a comma. I got to start with it the second time, right, with the X's. And then minus 0. And I don't know why I have a parenthesis either. Okay. So what does this equal here? This is going to be -8 over -4, which is positive dose. All right, so that's my slope, but what I really want is my perpendicular slope. So I do the opposite reciprocal, change the sign and flip it. I get -1/2. All right, so I've got my slope. That's awesome. Now I need to find my y-intercept. So let's do that. How about I use purple? All right, so if I take y equals, that is not a y equals mx plus b, and I plug in what I know, right, which that takes us back to this point. I know we didn't really use it for the slope, but there was a reason why we found that point. We're like, I'm going to need a point that's on the line. I need to know where it goes, right? Well, I can plug that in for my x and y, so I have -1 equals, and then I have my slope of -1/2, then my x is -2 plus b. I end up with -1 equals, well, -1/2 times -2 is 1 plus b. And don't be too quick with your algebra. -1 and -1, that gives me b equals -dose. Whew. Some of you might be like, oh, it's canceled out. B is 0. No. Be careful, okay? B is indeed -2. I have my two pieces of information. I can plug all this in. Y equals, there we go. Complete the Y. I'm just going to redo that because it bothers me. Y equals my slope, -1/2, x, my y-intercept, -2. Bippity boppity boo. That is the most challenging of these problems here, where I ask you to write the perpendicular bisector. I mean, you got to do so much. You find the slope of the line, got to do the opposite reciprocal. You got to find the midpoint. Then you have to go ahead and find your y-intercept. It's a challenging problem, one of the most difficult when it comes to this type of stuff. All right. So if you were able to handle that, you are Gucci Mane. And just keep in mind here, guys, all these writing equations of lines all stems back to knowing a point and a slope and getting that y-intercept, right? Once you have those things, it's very easy. It's just different situations giving you different information. But if you can get a point that's on your line, or 2 points to get you your slope, you'll be in good shape. Okay? Point and a slope, boom, you're going to be good to go.